He has more than 10 years of professional experience, and he will talk to you about continuous integration and continuous development. So please welcome Dincho Todorov. Dincho? Oh, he's getting ready. Give him 1 second. Yeah, okay.
Hello. So, I'm Dincho Todorov, and I'm doing site reliability engineering for Eternity. I'll try to explain how site reliability fits into the blockchain. So, more about me. I'm behind a computer for more than 20 years, and 15 more than 15 years in actual software development. I have a bachelor degree in computer science and technology. I'm still trying to complete my master degree, and I'm teaching students in our local university in Varna, and I have been CTO of various projects in the past. So, what's site reliability engineering? The term is coined by Google, and it's what happens when a software engineer is tasked with operational stuff. Yeah. And I think that's a really good definition of the role. It's not DevOps, right? We're doing DevOps, but in my opinion, there shouldn't be a DevOps role. So what we do in Eternity? We start with infrastructure provisioning, continuous integration, and continuous deployment pipelines, kind of doing the technical releases. Then that releases have to be deployed to I mean the nodes that we currently manage as Eternity organization. Of course, monitoring, and there's a few services and tools that are centralized but help the adoption of the protocol more easily. So when I started working for Eternity, I think 2 years ago or something like that, there was the project was very, very young, and there was basic tests, very basic release process, no infrastructure, no testnet, and of course no mainnet, and that was fit in a basic Travis configuration. So I was tasked to run the testnet immediately for yesterday. So I started by running few nodes in OpenStack code provider. Why OpenStack? Because someone already took that decision at that time. We used OpenStack Head. It's a tool that you actually use configuration to run your nodes. Two basic playbooks, one to set up any dependencies of the node and to prepare the virtual machines, and of course a deploy playbook that actually deploys the node. And that was tied with Travis, so everything was automatically deployed. Then almost immediately we started facing issues with Travis. It's a great tool, free for open source, and our project fit that, but they're using shared queues with workers for their open source free service, and that was starting to be a big bottleneck for us. So we started looking for other alternatives, and we tried to start paying for. At that time, their paid service was at the .com TLD. So we tried to start paying for more workers and some dedicated resources, but it was kind of obvious and hard to run an open source project on paid service, their paid service. However, they was, I don't know why exactly, but they was unable to provide more than few workers for us. So we tried to run our own set of Travis infrastructure with Travis Enterprise, but we had performance issues at that time. I think it was because the cloud provider we was using. So someone suggested to try even Jenkins. I think it was Michal. That was also failed because of the same performance issues, actually. As far as I know, the SDK teams are still running their own Travis. So we end up in Circle C, and we're so Circle C service since then. What we have now, our build pipeline is consists of 28 jobs, and some of the jobs have more than one task. So it's 40 tasks for each commit that runs every single time someone push a change. Our release pipeline is slightly more complex because of more checks that have to be done and more additional steps to deploy to the actual GitHub release, push the Docker containers, and etc. So last month we had 5,000 build hours run in Circle C. That's a lot of time, in my opinion. So we are Circle C is spending a lot of time ensuring that our code is actually well tested and safe. And of course, this is a lot of configuration. We have 1650 lines of Circle C configuration only for the Erlang node repository. And of course, we have a lot of repositories. So that's more than 4,000 lines of Circle C configuration code. And it's EML, single files. So, as I said, at the beginning we started using OpenStack Head and OpenStack at all. But we shortly realized that it's kind of limited compared to the other providers. So we started looking for alternatives, and of course, we started using AWS. Back in the time, during the migration, we was running both at the same time. So we had AWS CloudFormation, OpenStack Head run by Ansible for synchronization of the variables and the other, for example, secrets. Then we realized it's not worth it to support multi-cloud because it's actually a lot of more time to waste for that. And of course, at some point, hate that code formation was not enough, so we migrated to Terraform as our tool for configuration of the infrastructure. So, since the beginning, we were following the mantra of infrastructure of code, and we have 3 Terraform modules, especially for Eternity and our nodes. We have 6 additional repositories, like for the testnet, mainnet, API gateways, whatever services we're using. And the configuration and the bootstrapping scripts are in their own repo. At the beginning, we started with a single repo that was containing all the configurations in that, but since the team has slightly grown, there was a really nightmare to actually get some changes in. So what's the benefit of the infrastructure as code? Of course, peer reviews. We do peer reviews on each change of the infrastructure. You can easily see during the review what that change will actually, how does it apply to the Wi-Fi infrastructure. We run a lot of integration tests, and of course you have blame history. So I want to talk about a bit the terms we use for what's network and what's environment in our configuration. So network is an actual blockchain network, which is a set of peer-to-peer nodes, of course, following the same consensus protocol. But environment is just a set of configuration of different nodes that can actually, you can have multiple environments running, joining the same network. But the environment is not actually a network, and the opposite. So what you have, right now is the mainnet network, the testnet network. Sorry about the ID. Back in the days, it was the ID name was taken from the environment name, and we decided to keep the data of the testnet. This is why the ID should be kept as well. So, and we have a next network. That's actually the next consensus protocol, which kick in at block 3, depending, but the very first blocks. So you are always running the next protocol there. In regards to environments, there are a lot more. In the mainnet, we run the seed nodes, which is different environment. We run the API gateway, also known as SDK gateway. We run a small set of nodes that does active protocol monitoring by posting transactions and metering things. And almost the same for the testnet, plus we have an integration environment, which is running the master branch connected to the testnet. And the next network, as I said, is just a simple set of nodes that's both seeding the network and mining. And yeah, we have a couple of tests and development environments that are used mostly internally. So this is what it looks like. This is the networks grouped by environments. We have more than 100 nodes for the different networks, mainly on the testnet and mainnet. And this is the distribution by region, so we are deploying multi-region always. I think it's 6 regions. And yeah, this is the opposite grouping. So we are running mainnet seed nodes in 4 regions, as well as the testnet nodes. We have few basic services. That's the one-line quick installer that you can actually source from Bash and install your node without taking care. It's taking care for dependency installation. The node documentation. By node documentation, I mean the Erlang reference implementation of the node. And API docs, of course, that Emin showed in the previous slide. The mainnet API gateway, testnet mainnet gateway, API gateway, and 2 artifacts repositories about builds, releases. And there's we take periodically snapshots of the databases because right now the syncing process is a bit slow, so we have to start from somewhere when we bring new nodes. It's not yet public, but I want to make it public soonish. In regards to Docker images, we are supporting few images. That's aeternity, the Erlang reference node implementation. Sophia, HTTP compiler, some internal images that we're using to build all the things. That's Eternity Builder, so you have all the dependencies, all the tools already there. And of course, Eternity infrastructure is some kind of console that you can just download and deploy a node with a few parameters and a single line of make target. And there's a Docker Compose configuration called localnet that runs a couple of nodes, so you can do some testing locally without spending too much for installation and configuration. That's it. Thank you.
Sorry, my bad. Let's have even 2 questions, I think. Who's going to ask the first question? Come on. Who's going to be the bravest? I mean, I think you have a question. You understand everything? You know how to deploy everything? Right, now we have a question. Right. Excellent.
I have a question about integration tests with Eternity. Like,
Yep.
do you have any recommendations how to run your node locally, and any recommendation how to test it?
The easiest way is always Docker container. If you don't have to mine and you don't care about performance too much, just run the Docker container.
Any more guys? Anyone else wants to have a go? I told this is the most important man. I mean, he's doing everything for you, basically. Right, go on.
Okay, so let me ask. Which cloud services do you use? Are you like putting everything on your own private, using AWS, anything else? And why?
We use mainly AWS because of the tooling, actually, because of the wide support of the tooling. We tried to do multi-cloud with Google as well, but as I said, multi-cloud is, we need more people to spend time on it because it's really taking time. It's not like as advertised.
Okay, and for the basic integration test, are you using the, let's say, common
By saying integration test, I mean the integration test of our infrastructure and the configuration code.
Okay.
So if you change the actual configuration, we bring a couple of instances, test if they're going to deploy with really basic health checking, and that's it.
But
But it spans multiple nodes every time you change the infrastructure code.
Right, but are you using like a common CPU units or rather GPU units?
Unfortunately, we are, if you're talking about GPU mining, it should be part of the node testing, right? It's not about the infrastructure.
Well, in general, yes. How do you? I mean, the network you set up is based on the GPU.
No, it's
Internally.
not GPU. It's CPU based and it's with low hash power, but it's testnet. I guess the better way is, as we are discussing proof of authority or something like that, alternatives for the testnet.
Right. Thanks.
Thank you. Thanks. Yeah, thank you, Dincho.